in our three types of problems. So all we're doing today is solving equations and inequalities, but the solution looks different depending on which one you are given. So the first one, we wrote down these rules yesterday. We said if x is equal, the absolute value of x equals a, then x could be a or the opposite of a. Right? If you think about what that means, absolute value tells you how far something is from 0. So if I say the absolute value of x equals 2, that means it could be 2 units away from 0. So it could be 2 or it could be -2. So we get those two separate answers. Okay. So if it's an equation, you're just getting two answers, x equals those numbers. The inequalities are the ones that are a little bit harder to think about. So if I said the absolute value of x is less than 2, what that means is I want everything that is within 2 units of 0. Okay, so anything that's closer than 2. So all of those numbers are less than 2 away, and all of these numbers are less than 2 away. Would you guys agree with that? So yesterday, the rule we wrote down is x has to be in between the negative and the positive. The trick, I think Mrs. Keller used to say less than, that's an and statement, so it's in between those two. Your solution is always going to be a single thing. So if it's a less than, that's an and, we get one answer. But I do want you to give me the interval. So anytime you have a less than, you are getting a single interval for your answer because it's all of those numbers between -2 and +2. When it is a greater than, so what we wrote down yesterday, x is greater than a or x is less than a negative a. I think what you were told in the past, this is like a great or. So those are or statements when you have a greater than. If I said the absolute value of x is greater than 2, that means I need everything that is more than 2 units from 0. So that would be everything bigger than 2 and everything smaller than -2. When you write your solution for those, you are getting two separate pieces. -infinity to -2, union 2 to infinity. So on the equations, your answer will just be two numbers. The inequalities, I'm expecting intervals because it's all of those numbers in that window. Less than, you should always get a single interval in between two numbers. Greater than should always be two separate pieces. So what we're going to do is just practice solving these now. The key, before you can write your problem without absolute value symbols, you do have to get the absolute value by itself. So if there's anything else on that side of the equation, we may have to reorder some things first. So if I asked you to solve the absolute value of 2x plus 1 equals 7. So this is an equation. That means I should just get two answers. To find my answers, okay, I do my two separate problems. So I say 2x plus 1 is equal to 7. And 2x plus 1 is equal to -7. Okay. So then if we solve these, subtract our 1, 2, I get x to equal 3. On this one I get -4. Those are my only two answers. Those are the two values of x that will work. You can always check them. If you put in a 3, absolute value of 7 is 7. If I put in -4, the absolute value of -7 is 7. So you can always check by plugging them back into the original. What if I gave you this one? What would we have to do first? You have to get the absolute value by itself before you write your two equations. So I divide my -3. And now I can make my two equations. So 4x plus 5 equals 5. Or 4x plus 5 equals -5. Subtract my 5, divide by 4. And get 0 and -5/2. And again, if you want to check them, what do? Plug them back in. And they're both going to work. If I put in 0, -3 times 5 is 15. If I put in -5/2, then I get the absolute value of -5, which is 5, times -3 is 15. I want you guys to do this one. So first, get your absolute value by itself. Your absolute value by itself, and then you set it equal to 9 and -9. So you get x to be 13 and -5. Are these equations okay? Biggest thing is make sure you get the absolute value by itself before you set it equal to the positive and the negative.
Isn't the absolute value of x minus
Anything else? So let's talk about the inequalities. Think back to those rules we wrote down yesterday and I was talking about at the beginning. If it is a greater than, you should be thinking that's or, and so your answer at the end will be negative infinity to something, union something to infinity, because it gives you two separate pieces. Less thans are and statements, and so your answer should just be something to something. Okay, we get a single interval at the end. We have to start out the same way, getting the absolute value by itself, and this one is. So then we have to decide, is this an and or an or? So when I look at it, greater than means or. So you do two pieces. The first one, all you do is drop the absolute value. For the second one, you have to flip the inequality and make it a negative. Just like anytime you multiply or divide by a negative, it flips the inequality. So when I do the -8, the inequality turns around. Now we solve both of these. So we add over our 4, divide by 2. This one I add my 4, divide by 2. I expect an interval at the end. If you need, you can always draw a picture to help yourself. I'm not going to require it, but it's certainly helpful. Greater than or equal to 6 is everything starting at 6 and going up. Less than or equal to -2 is everything from -2 down. So my interval is -infinity to -2. It gets a bracket because of the equal to. Union bracket 6 to infinity. Okay, let's look at this one. What would I do first? Isolate. So subtract our 6. Alright, once it's isolated, I look. Less than. What does less than mean? And. Okay, I know ands are just going to be in between two numbers. So I always set this up for -6 to +6. So you basically take this inequality, put another less than and -6 on the other side. We're going to solve a compound inequality here. You can write them as two separate ones, you just have to interpret your answer a little bit more at the end, so this just makes our answer easier at the end. When you're solving these, whatever you do in the middle, you do to both ends. So you get -5 is less than 3b is less than 7. Divide everything by 3, so we get -5/3 is less than b is less than 7/3. And I'm expecting just a starting and a stopping point. And when it's written this way, I have it. It tells me it starts at -5/3 and it ends at +7/3. So ands only have a single solution at the end. I want you guys to try one. Make sure you isolate first. Did you get the absolute value of x plus 2 is less than 19/5? So you subtract your 3, and then you divide by -5. And since you divided by a negative, the inequality flips. So then less than tells me it is and. So we just put it between the negative and the positive. So we subtract 2 from everything. So we get -29/5 is less than x is less than 9/5. So it's just saying x is between those. There's no equal to, so it gets parentheses. Starting at -29/5, ending at 9/5. Ands are always just a single interval at the end. So less than, you get one interval. All right. Should we do one more? Okay. So what's our first step? Isolate. Add over that too. Okay, once it's isolated, I look. Greater means or. Or is two separate ones. The first one, you just drop your absolute value. With the second one, you flip the inequality and make it a negative. solve each. Subtract over our 4. When I divide by -3, what happens? So I get less than or equal to -5/3. This one is subtract my 4. Divide by -3, which will flip it. Greater than or equal to 13/3. We know OR is union. So I should have 2 intervals. If you can write them from there, great. If you need a number line, you are welcome to draw it. Equal to means bracket. You're less than or equal to -5/3. You are greater than or equal to the 13/3. So it's just -infinity to -5/3 with a bracket, union, bracket, 13/3 to infinity. Questions on that one? So you have to pay attention to if it's an equation, a less than, or a greater than. It changes our format. The next slide I want to put up are 3 problems that we actually don't even have to work out. We can just look at them and answer if you recognize it. So they're all basically the same. I said 3x plus 5, and then I have equal to -5, less than -5, and greater than -5. So we look, all of these have a negative over here, right? Anytime your absolute value has a negative on that side, you really don't have to solve it, you just have to think about it. An absolute value is what kind of number? A positive. When will a positive number equal -5? Never. So if the absolute value is by itself equal to a negative, it's just no solution. On B, absolute value is positive. When is a positive number smaller than a negative number? Never. C, when is a positive number bigger than a negative number? Always. Negative infinity to positive infinity. So, if you have a negative on one side after you isolate, you don't really have to solve them. You just have to look at it and think about it. Any questions there? All right, last slide. These are the 2 trick questions that look a little bit different, so we need to pay attention to that format. How is this one different? Absolute values on both sides. Okay, it actually changes nothing. What do we normally do? We drop the absolute values for the first equation. And what do we usually do for the second one? We set it equal to the negative. When you do that, that is the piece that you have to watch. You have to do the opposite of that entire side. Okay, I want you guys to solve it from there. So it's an equal to, you're just getting 2 answers, not an interval. Solve our 2 pieces. To distribute that negative, and you do the right hand side. So did you guys get 9 and -1 for your answers? Okay. the last one. So this is the last type of problem that is slightly different. How is this different than the other problems we were solving? I have two terms over here, right? All the others are just equal to a number. When I have a variable outside my absolute value, I am going to have to make sure I check those because we could get answers that don't work. Now we solve it the same way as we did the one above. You set x plus 4 equal to 3x minus 1 and the opposite of 3x minus 1. So we're going to do our two equations. When I solve these, so if I subtract over my 3x, subtract my 4, and divide, I get 5 halves. Over here we distribute a negative. We add over the 3x, subtract over the 1, or the 4, we get negative 3/4. All of the others worked because it was just a number outside our absolute value. Because this one also has a variable, we need to check those. So if I plug 5 halves in, over here, 5, that's the value of 6.5. Over here equals 6.5. So does 5 halves work? Yeah, that's fine. Okay, if I put in negative 3/4. So on the left, I get the absolute value of 1.25 equals negative 1.25. Does that work? Sorry, it's not 1. It should be 3.25 on both. But anyway, does that work? No. So this one did not check out. So on this, 5 halves was my only answer. So you just have to be careful. If there's an absolute value or an x outside the absolute value, check your answers. You might get something that doesn't work. So I have a handout for you. We've got about 20 minutes. I would like for you